Yes.
Yeah.
Now you are good to go. You can start now.
Okay, so I'm going to talk about the blockchain history. A brief history about blockchains, how it all started, and where we are now. In 1998, an engineer called Wei Dai published a paper which described a new electronic cash system that is based on a protocol which does not require any real money for the transfer of funds from one account to the other. This was an era before the credit cards became so popular. Now, a groundbreaking paper that was entitled Bitcoin Peer-to-Peer Electronic Cash System was introduced in 2008. And this paper was written by an entity. We don't know if it's a man, a woman, a corporation, or what we know is that it's an entity. And he used a pseudonym called Satoshi Nakamoto. Right? Up to now, nobody knows the real and true identity of Satoshi Nakamoto. And he coined the term chain of blocks. But over the years, this term chain of blocks has evolved over the years into the word blockchain. Okay. So in this presentation, I'm going to talk about, give a brief overview about what the blockchain is, some of its uses and applications. If you want to start a career as a blockchain developer, what you're supposed to do, types of blockchains, and then the Ethereum blockchain, which is a public blockchain, Solidity programming language, which is a high-level programming language that we use in writing smart contracts, and then technically what a smart contract is. After that, we'll do a small short demo where we'll explain the various parts of a very simple Solidity smart contract, deploy it, and then give an explanation of the various parts of the smart contract. Okay, so that is a brief overview for this presentation is going to be about. Okay. Now, so what is a blockchain? If you're a layman on the street and you hear the buzzword almost these days everywhere, blockchain, cryptocurrency, this and that, and then somebody asks you to explain what the blockchain is in very simple terms, in the layman's view, layman's definition, in very simple terms, what are you going to say? So simply, a blockchain, in a layman's definition, is a secure shared record-keeping system in which each user holds a copy of the records. And these records can only be updated if all the parties involved in the transaction agree to update it. So what is a record-keeping system? A record-keeping system is something like a ledger. You have a transaction between two parties, and then whatever transpired between you, you keep a record of those. Normally we use a ledger to record those transactions. So in a blockchain system, we have all the participants, people who are participating in the blockchain. Okay. Instead of keeping individual copies of whatever transpired on the blockchain, everything happens on the blockchain itself. And how do they keep records of this? Before any record is agreed upon and cemented the blockchain, each participant must agree that what we are trying to add to the chain of blocks or the blockchain we agree that everything is okay, perfect. If one individual, one person, one entity among the participants says that no, we don't agree that this data or this information should be added to the chain, everything is rejected. Very simple. Okay. You want to add a transaction to a chain of blocks, you broadcast it to everybody, all the participants. Do you agree? Do you agree? Do you agree? They said yes. Okay, we add it. Do you agree? 3 out of 4 say yes. One person says no, then it's the whole thing is rejected. Okay, so that is the layman's definition. Simple, straightforward. But technically, okay, if you want to go deeper, be a technical person, a blockchain is actually a peer-to-peer distributed database, and it is cryptographically secure. It's also append only. It's extremely hard to change. What we usually say is that the blockchain is immutable to some extent. It's not 100%. Sometimes you can change things, but it's extremely hard to change. And you can only update it through consensus. What consensus is that? The consensus is that all the peers on the network, everybody who is participating on the blockchain should agree. Otherwise, nothing can be appended or updated to the blockchain. It's a very, very simple concept. Now, when we say something as a peer-to-peer, what it means is that there is no central authority controlling the blockchain. These days, in the normal market, in the real world, if you want to buy something from online, from an e-commerce company, there is always a central authority, somebody who controls transactions. And whatever you buy goes to them, they decide when to send you this and that. In a blockchain, it's peer-to-peer. All the different nodes in the system communicate with each other. There's no third party who is controlling anything. There is no outside entity involved in the transactions. The system has so many different nodes, they communicate with each other. And when we say it's distributed, data is shared among all these peer-to-peer nodes on the network. So it's distributed and it runs autonomously. No third party is controlling anything. It runs by itself.
Sorry, I'm interrupting you. Can you put some of the students are texting me or messaging me that they want to see the whole screen in a presentation or kind of the screen rather than the way that you have it. Can you just put it in a full screen mode?
Full screen.
I think click on the play, maybe or something like. There's a click and there is like next to the play. Or you can click on the F11. F11 in Windows is F11. I'm not sure if the Mac or command 11 or something.
Okay, hold on. The full screen here.
Yeah, click on the Keynote Live. Maybe that's the one.
There's a document here. No.
Yeah, Keynote
Live.
Oh,
Keynote Live, yeah.
Yeah.
No, that's not it.
No, that's not the one. Click on the play next to it. Play.
Okay.
Oh, yes, perfect.
Now, okay. They can't see the screen. Hold on.
No, it's perfect.
Okay. All right. So I said that technically a blockchain is a peer-to-peer distributed database. It's cryptographically secure. We use cryptography to hash data before it is stored on the blockchain, because we want to make every data or every information on the blockchain tamper-proof, and no hackers can steal any information. We use special algorithms, cryptographic algorithms. They differ from blockchain to blockchain, but in the real class, we're going to talk about some of the algorithms hashing algorithms that we use to make data on the blockchain secure. And it is also append only, meaning that whatever goes onto the blockchain stays. You put something, for instance, if you have a degree and you decide to put it on the blockchain, it stays there. You append, you don't take things out of it. You don't remove things out. Once it's on the blockchain, once it gets onto the blockchain, it stays there forever. And it's also extremely hard to change. That is what I just talked about. You append and then it stays there and it becomes immutable. Okay. And if somebody decides to send a transaction to the blockchain, it can only be accepted if all the participants on the blockchain agree that this is something that we believe should be added to the blockchain. If there is any doubt at all from anybody on the blockchain, any of the peers, the whole transaction is rejected. Very simple and straightforward. So technically, a blockchain is a peer-to-peer distributed database, cryptographically secure, append only, extremely hard to change, and is only updatable through consensus. Okay. So that is a layman's definition. And then the technical definition of a blockchain. To move on. Okay. Okay. So now we come to how a blockchain works. Okay. When we say a blockchain, we're talking about a chain of blocks. So what is a block? Usually a block is transactions that have been bundled together to form a block. So most of the data or the operations that you see on a blockchain are all transactions. So what are transactions? Just messages, sending messages from one account to another account. Messages from one account, account A, for instance, to account B. That's what the blockchain is. That is what a transaction is. So in this diagram, we say A wants to send money to B. So A is an account A, wants to send money to an account B. Okay, so that action of sending money from account A to account B, we call a transaction. Okay, and so this transaction is represented on the blockchain as a block. Okay, so the first thing the blockchain does is that it will have to broadcast this to the whole network. Every party or every node on the network must be aware of this, that account A wants to send money to account B. Okay, so those in the network, every node in the network have to check this and make sure that they agree. Is the transaction valid? Based on the algorithms in the blockchain, okay, do you agree that this transaction should proceed? And if everyone agrees, yes, the transaction is valid. Because of that, it is added to the chain. And then after that, the money is sent from account A to account B. If one node on the chain of blocks decides that, no, this transaction is not valid because of this and that, the transaction is rejected and it's not added to the blockchain. It's that simple. So the takeaway here is that every transaction must first of all be broadcast to every party on the network. Then every party on the network must approve that the transaction is valid before it's added to the blockchain. Very simple and straightforward. And after that, the transaction can proceed. If there's any problem with it, the whole transaction is rejected. And then it's reverted. Okay. Next slide. Okay. So the name is blockchain, it's a chain of blocks. And these blocks are transactions bundled together. And the way they are bundled together is that each block is linked to the previous block. There's always a reference from one block to the block behind it or before it. Okay. The only block in the blockchain that does not have anything in front of it, any block in front of it, is called the Genesis block. Okay, Genesis block. And it's the first block in every blockchain. After the Genesis block, every block that comes after the Genesis block is linked to the block after it. There's always a reference to it. And because of that, if a program, an individual, somebody tries to tamper with it, it's immediately broadcast to all the peers, all the different other blocks on the blockchain. And then everybody will be able to know. So it's a very, very secure system. I mean, nothing is perfect in this world, but it's a very, very secure system. And because of these linkages, it makes the blockchain very, 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 secure. It's tamper-proof. You try to do something on one block, it's immediately evident on all the other blocks. Okay, so this is what this slide is trying to show. Okay, now talking about how popular the blockchain is and its adoption in the industry. There was a survey, okay, conducted in 2008, that was last year. And then participants were asked about whether they are using blockchains, whether they intend to move into or adopt blockchain. And we realize this, even though it seems the market is improving, not everybody is on board yet, meaning that there's still a lot of opportunity and there's a lot of opportunity and room for growth in this field. Because even though it seems to be the buzzword these days, its total adoption is not very complete yet. So there's still room for growth. That is what this slide is trying to show. Okay, we'll come up to blockchain uses and its applications. For any new technology to be useful, it has to be able to solve problems. Okay, so we're going to talk about some of the problems that exist in the real world and how adopting blockchains will help you to solve some of these problems. So what are some of the kinds of problems blockchains solve? In the normal world, where two people decide a transaction, person A is selling an item and person B wants to buy this item. The first thing that comes to mind is the word trust. Trust. If there is no trust, somebody doesn't trust you, that the item he's trying to buy from you, you deliver exactly what he wants. He's not going to buy it from you. Trust is very, very important. There is an acronym called TTA. Trust, transparency, accountability. These three main things, these are three main areas where the blockchain is very, very, very useful. You need trust to be able to buy something from a vendor. Okay, and how does this trust evolve or come about? Usually you use the history. If I bought something from you before in the past, right, and then it was delivered successfully, that history tells me that in future, if I want to buy something again from you, you're going to repeat the same thing. If the history is bad, I don't trust you. So I will not even come to try to purchase anything from you. History is very, very important. That is why when you go online to buy something from an e-commerce store, they have a history, a feedback, and then a reputation of all these vendors over there. You trust people based on what they did in the past. And based on that, you think that they are going to do the same thing. Okay. Your reputation is also very, very important. Okay. In the blockchain, we say it's a trustless system. We don't need, because you are not dealing with human beings. You want to transfer cash from account A to account B. There is no human being, third party involved. Okay. The blockchains has a system to make sure that everything, all the different parts are moving right, and then the transfer is done. So trust is the first issue or the first problem that blockchain solves, because no human being or no third party is involved. It's also transparent because in the normal world, when two people are making any form of transaction, what they do is that they keep ledgers. You record the transactions on your own sheet of paper, I do mine. Whatever you are writing on yours, I don't know. Whatever I'm writing on mine, you don't know. In a blockchain system, this doesn't happen. It's very, very transparent as opposed to being opaque. Transparent because the transactions are available online for everybody to see, to know. There is a website called etherscan.io. So you go there, everything is public. It's also the issue of, addresses the issue of accountability. Accountability because instead of finding a third party like an accountant who'll be doing bookkeeping and all these things, the blockchain takes care of that. A lawyer, there's no need to find a third party like a lawyer, accountant, anybody else, or even a couple or anything, because it's a trustless system. Everything is transparent and accountability is taken care of. So as of now, there are a lot of applications and there's so many industries that are getting on board in the blockchain industry. Healthcare, pharmaceuticals, cross-border agencies, IBM, food safety, diamonds, voting systems. All these companies are trying to get on board in the blockchain. And these companies are trying to get on board because they believe that there are problems that this new system can address. Okay. Some of the very popular companies that you may all be aware of, UPS, FedEx, they're all trying to get on board. So the future is good. So next slide. Okay. You're planning a blockchain development career. Blockchain engineers are mainly developers with software engineering or web development background. If you're a software engineer, you know any of these compiled languages like C++, C, C++, Java, and the language of the web, JavaScript. You have a very good and wonderful chance to become, because an extension of these languages. So if you are a software engineer, a web developer, transitioning from your current skill into a blockchain, a career, it's not that difficult. Just a continuation.
Quick question.
Yeah.
So how much, since you mentioned that you need a background in software engineering or as a software developer, how much experience and knowledge do you need, like, in order, like, to be solid?
Okay, the short and simple answer is that it depends on the individual, right? There's no one answer to that question, sir. Depends on the individual. But the reason why I said this is this. The Solidity programming language that we use to write smart contracts on the Ethereum blockchain, okay, is very much like C++ and then JavaScript. So if you know C++, it doesn't mean that is if you know Java, if you know C++, it will help you. If you don't know this at all, you can also quickly pick it up, because Solidity programming language is not exactly the same. It's similar in some respect, but there's so many things that are different from C, C++, Java, and then JavaScript. It's a language on its own, okay? So it depends on the individual. Some people may need 2 years, some people may need 1 year. You know, some people may need 3 years. So normally we say that we need between 1 to 3 years software development experience. Okay, all right. There are also new areas like blockchain security architect, blockchain architecture, blockchain designer. All these things are coming. And like I said, it's an evolving field. It's a very new field, but it's evolving. Okay, and then as it evolves, new functions and new use cases are coming up. And then the industry is changing, keeps changing all the time. So these things will keep changing. And like everything in this life, keep going on. Okay.
Okay, thank you.
All right. Okay, so something simple, what does a blockchain developer do? Okay, like I said, blockchain developers, they, among other functions, because every company is different, right? But among other functions, you'll be expected to write Solidity smart contracts. I mean, these are programs that run on the blockchain, okay? So you'll be expected to be able to run this, write programs, these programs that will be able to compile them, and then deploy them on the blockchain. And then make sure that the security aspect and everything is taken care of. You should be able to also have a very good knowledge about the blockchain industry in general, what is happening in the blockchain, software applications that run on the blockchain, what is happening in the industry. If somebody wants to be able to purchase any item through the blockchain using digital currency instead of using hard cash that like we do now as a blockchain developer, you should be in a very good position to be able to do that. Okay. If you join a company as a blockchain developer, they will expect you to at least be able to be comfortable with understanding how the blockchain works, to be able to describe the various maybe parts of the blockchain, how it works, and be able to, at a minimum, you know, write code that you can compile, deploy on the blockchain, and then let it run. Then be able to, if somebody asks you to assist them to purchase something through using digital currency, you should be able to do that. And these are some of the things that we teach in our class. Okay. This slide is subjective. Sometimes it depends on how bearish or bullish the market is. If, like every market, it's all based on demand and supply. If it's a bullish market and the demand for blockchain engineers or blockchain developers is very, very low, I mean, the supply is very low, then certainly they command a very, very high price. So this is to give you an insight into some of the possible money income that some of these blockchain engineers are making. But I can tell you that most of the time, experienced blockchain developers make six-figure salaries, 100,000, 120,000, 130,000, depends on your level of experience. If you are very new to the system, you can make 70,000, 80,000. It all depends on the market. It also depends on how experienced and how good you are. There are also software blockchain engineers who team up with other experienced blockchain developers to establish their own companies, because the industry is very, very new and is growing. It's always changing. So if you are very good, you can easily think about getting a startup. So this slide is to give you an idea about what the industry is all about and some of the potential salaries blockchain engineers earn. But again, it's all relative. It depends on the market, but very experienced, very good blockchain developers and engineers can earn six-figure salaries. Okay. In 2017, there were some of the websites you go online, maybe because the industry was very new. The demand for blockchain developers and engineers were very, very high. As of now, things are not as they were before, but it's actually a bearish market, but in future things can change. There was a time when the Bitcoin started, Bitcoin is a cryptocurrency. When it started, the value was very low. It went all the way up to 20,000. And then right now it came down again to less than maybe $4,000 per Bitcoin. So these are issues that are not controlled by human beings. The markets will determine these things. But because it's a growing field, it's a growing discipline, the potential for growth is very, very high. And all the big companies are getting in. IBM, Amazon, Facebook, and Microsoft they are all getting in blockchains. Okay. So this screen says that 400% demand increase in 3 years tells us that the industry is growing at an accelerated pace, which is true. But again, it all still depends on the market and what happens tomorrow. The potential is there. And if you have any dreams to get into the blockchain industry, I think the time is now. Now that it's growing very fast. You can get your foot in the door. And then when it grows, you grow with it. Okay. So this slide shows some blockchain developer jobs. In the US, you have some in Arlington, Virginia, Washington, DC, LA, Florida, all these other places. Okay. Some of these jobs are even advertising for blockchain developers remotely. If somebody who is comfortable working remote, you can easily apply for some of these jobs that allow you to work from your own home instead of always commuting to work.
Question,
Okay.
are you working remotely or are you in office?
Pardon me?
I was
Yeah,
asking if you...
remotely means that you are not there physically. That is all what it means.
No, I know what remotely is. I'm asking you, are you
Yes.
working remotely?
I'm working remotely?
Yeah, it's a question.
Yes. I'm working remotely, yes.
Okay, thank you.
Okay. All right, so this slide shows some of the job titles of potential workers in the blockchain industry. Okay, and actually this was on Indeed.com. This was research done by a group, and it's all on, just called from Indeed.com. Data scientists, cryptocurrency, cloud engineers with Bitcoin protocol, and all these things. Product manager, cryptocurrency certified cryptocurrency specialists, and there is sales associate, systems engineers, and all that. So it tells you, gives you some idea about what the industry is looking for and the potential that exists in that industry. Okay. Now, these are some of the things that, some of the functions that a blockchain engineer is expected to perform. Develop blockchain applications using Ethereum and Solidity programming language. Develop secure public ledgers, run security checklists prior to blockchain application deployment. You test, debug, and deploy decentralized applications, perform a unit tests. Develop blockchain applications using IBM Hyperledger Fabric. Maintain blockchain applications with periodic backups. Integrate blockchain applications to current system. Develop secure APIs for blockchain data exchange and all that. Yes, and again, every company is different. So this is just an idea about some of the functions a blockchain engineer or blockchain developer will be expected to perform in a company that decides to hire you. Okay, this slide shows that your qualifications, potential qualifications, 3+ years with hands-on coding experience in 2 or more of the following languages: C++, Java, Python, Golang, JavaScript, Node.js. So again, everybody is different. Somebody with 2 years experience can still do that. Somebody with 3 years, 4, 5 years experience can do that. 1+ years of experience in smart contracts and consensus algorithm and development. Okay. And then you must be able to possess expertise with developing well-designed REST APIs, and possess strong analytical skills like programmers are supposed to. And then possess proven experience with Solidity, Rust, Lisp. Rust is also another high-level programming language that used in writing smart contracts. But in this course, we will be dealing specifically with Solidity because Solidity is very, very popular.
Raynon, sorry, I'm interrupting you. I'm just looking at the timing because all the students have this slide. I think for the lack of time, we
have to go fast.
Yeah, a little bit go fast because
okay.
Yeah.
Okay, so this is almost the same as the previous slide. Okay, required qualification. Okay, and okay, so decentralized dApp. Sometimes you hear about dApps in the blockchain arena. Or what it is a software program that run on the blockchain. Okay, software programs that run on the blockchain. It's a dApp. We call it a decentralized applications. Okay. and you go to this link on YouTube, you see examples of dApps. There are other websites like dappreader.com and all this. They all have so many dApps available, but this is a link to YouTube that shows you. Okay, so distributed ledger. I think we mentioned this in the beginning slide, that a blockchain is simply a distributed ledger. Okay, a ledger is a record-keeping system. Okay, and it's distributed because it runs from peer to peer. Right? There's no centralized data storage. Okay, and then it also runs autonomously. Okay. Okay, so now we come to the overview of Ethereum, Solidity, and smart contracts. So what is Ethereum? Ethereum is an open source blockchain based on a distributed computing platform. So Ethereum itself is an implementation of a blockchain. It's a public blockchain in itself. Public blockchain because you don't need special permission to join. It's public, available, anybody. We have other blockchain systems that are permissioned, like IBM Hyperledger, for instance. You need a special invitation to be able to join. Ethereum is not like that, it's public, open. Okay, so anybody can join. Okay, and Solidity. Solidity is a high-level programming language similar to C++ and JavaScript, and it is used for writing smart contracts. Okay, so what is a smart contract? Smart contract is the compiled bytecode that runs on the Ethereum virtual machine. We'll talk about that shortly. Okay, so Ethereum, we said the blockchain runs autonomously, right? And there's an Ethereum virtual machine, just like the Java virtual machine. And this is the environment that hosts the smart contracts that run on the Ethereum platform. So we say it's a virtual machine, no third party involved, it runs by itself. But one thing that is very, very important to know that it is a completely isolated and sandboxed, completely isolated. The network systems inside the virtual machine, inside the blockchain itself, have very, very limited access.
The few fries there, Papa, in the other one.
Okay, has very, very limited access to the virtual machine itself. It doesn't want any tampering at all. So everything is handled completely isolated. Okay. And then one thing that is also very, very important is that it's a deterministic machine. Okay. Deterministic in the sense that if you ask it to send money from A to B, it will do that. So very deterministic because you can predict what it's supposed to do in the future. Okay. As opposed to it being stochastic, it's deterministic. Okay, so this is a definition, simple definition of Solidity. It's an object-oriented high-level programming language for writing smart contracts. And smart contracts are programs which govern the behavior of accounts within the Ethereum platform. And like we said, it's influenced by C++, JavaScript. And it is designed to target the Ethereum virtual machine. Okay, right, all right. Okay, so these are some of the programs that are used to write Ethereum smart contracts. Some of the high-level programming languages are Solidity, Viper, LLL, Serpent, and then the Bamboo. Okay, in this class, we'll be talking about, dealing most about with Solidity because it's the most popular language at the moment. Okay, so like we said in the beginning, blockchain has a reference to the block behind it. Okay, it's linked. And this is all what this slide is trying to show, that It's tamper-proof because of these linkages. It's tamper-proof. You do something to one block, it's immediately evident on all the other blocks in the system. Okay. Okay. So this is a simple example of a smart contract.
Yeah.
Okay. And we are going to do a small, simple demonstration and show what a smart contract is using the Ethereum Solidity programming language. And then we deploy it and then see how it goes. But it's very, very simple. It's very, very basic because you are beginners. You don't want to, you know, confuse anybody at this stage. Okay. So this is an example of a very, very simple smart contract. Okay. Okay. So if you want to write a smart contract, okay, as a beginner, there is an browser-based IDE called Remix, okay, called Remix. Go to your favorite browser, type in remix.ethereum.org, and it will bring you to this screen. This is the first thing that you see, this screen, okay?
Can you type it down in the text? Is a chat the URL so that they can see the URL?
Okay, that is it. You go here, this is the first thing, remix.ethereum.org. Instead of, it's very, very simple, very, very fast instead of installing all these Solidity compilers. Just go into your browser, type remix.ethereum.org, and it will bring you to the screen. Now you see that we have a code here that is given to us by, what is it, Remix. But this code is too advanced for our purposes. Now, when you come to this screen, the first thing that you see that this is divided into 4 parts, 4 sections. On the left-hand side, you see something here, browser config. This is what we call the file explorer. This is where you explore your files. In the middle part here, you see, this is the editor where you type all your Solidity code. On the right-hand side, you have the right panel. And then underneath here, below here, this is where you have your terminal or console. Let me move this, I need to move this out of here. No. Okay, this is the console. The console, whatever interactions that you have in your Remix IDE will be shown here in your console. Okay. Let me move this down. Okay. So you come here. Okay, hold on.
Reynold, I know because we don't have a time. We don't want even. This is not like teaching the coding or anything. We would like to see your demo project. So, like the project that you already.
Yes, I'm coming because I was doing it. You told me to do something. Just hold on a sec.
Because we already have 10 minutes time, so or 5 minutes, you know, because we just want to go over your demo project to see how you have, what's your project is and how you have deployed this, to have a sense of how much code has been involved in your project and what the project is doing. Raymond, are you there?
Yes, I'm here.
Oh, yeah.
Just a sec, just a sec. Okay. Okay. So we have this simple program here called simple storage, right?
Mm-hmm.
And the first thing that you see in, okay, I would like to, okay, this program that you see on the screen here is what we call Solidity programming language. It is not yet, this program itself is not yet a smart contract until it is compiled, okay? I want to make that distinction. When it is compiled and deployed on the blockchain, technically, it becomes a smart contract. So this is the Solidity programming language, okay? So the first line here is pragma, solidity greater than or equal to 0.4.0 and less than 0.6.0. So this first line simply tells that the source code is written for Solidity version 0.4.0 or anything newer that does not break functionality, but does not include a version 0.6.0. What happens with Solidity is that the language keeps changing very, very, very fast, okay? And there are different functionality being added to the language all the time. So you have to let the compiler know what functionality is available so that it doesn't break. Okay, so this is the first line. So with pragma solidity, and then you show the versions that you like to, you know, where the functionality will be able to, you know, run. So the first line here is contract, simple storage. Contract is similar to the word class in other object-oriented programming language. Java, we have class and then the class name. In Solidity, we have contract and then the class name. And you see that contract is what is it, lowercase c, and then simple storage. Okay. All what this program is doing is that it's trying to, we have a storage variable, and then we are modifying the storage variable, and then we are trying to retrieve it. That's all what it is. Okay. So this is a very, very small contract. This here, uint stored data, is a simple state variable, right? That this contract, you know, is storing. And then this function, which is the method, has a local variable that is trying to modify this. And then this function here will retrieve that stored data. So what you do here is that you go to this compile tab on the right-hand side, okay? And what I do here is that you check the auto compile, okay? Check the auto compile the first time because we just pasted this thing, okay? Once you click this, you see down here, down below, that the name of the file has appeared here. Very simple, okay? And then next, you go to the run tab, okay? So simple storage is also here. We have two buttons here, deploy and then all address. You click on the deploy, click it. Okay, sorry. Now, before you do that, it's very, very important. I did this on purpose. On the right-hand side, this environment that you see over here is very, 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 very important. Okay, you go to this tab, you see injected Web3 and then Web3 provider. When you're trying to deploy a simple smart contract, okay, use Java virtual machine, use JavaScript virtual machine, JavaScript VM, okay? If you don't do that, your contract will not deploy. And that is why I did this. Okay, so select JavaScript virtual machine. And then we have account, gas limit, we'll go all over that. And then you click deploy. Once you click deploy, down here, you see deploy, under deployed contracts, you see the name of your smart contract here. There's a little arrow here. You click on it, and then you see these two functions, the set function that we wrote here, and then the get function here. And then what this set function is asking for is uint 256 unsigned integer. So let's put something in. Unsigned integer means it can only be positive. So we put the number 5 in, and then we click set. Okay. Let me bring this in here so that you can see my console. Okay. Anyway, and then after that, you click get. Okay, then you see right away underneath here that the number 5 that was set, the function get has been able to retrieve it. Okay.
So, Raymond, so basically this is a very basic, simple idea.
This is a very, very simple, because there are so many gotchas, so many nuances, and in a smart contract, right? Mm-hmm. It's a very, I won't say very, very complicated program language, but for each contract, it contains the declarations of state variables, functions, function modifiers, events, struct types, enum types. Furthermore,
oh my gosh.
Yes, furthermore, contracts can also inherit from other contracts. And then there are also special kinds of contracts called the libraries and interfaces. So all these things, so many things involved in the Ethereum, what is a smart contract?
Yeah. I think now I understand the complexity of it, and that's
it's
why
it's very complex. It's a very complex, and it's a statically typed language. It believes so much in types. Types is very important. If you make a mistake and it don't, let's say here, instead of saying uint, okay, you see you straight away you get a red, okay, you get a red notice. Okay, here.
It's a syntax error, yeah.
It's a syntax error.
Yeah.
Okay,
yeah.
You have to be very careful with this because you're dealing with money. You're dealing with money, right? And so make sure that it's not forgiven. And anyway, if you make any mistake, the Remix IDE is going to signal that and tell you that you have a problem here, you have a mistake here. But one thing I want to make clear is that the Solidity programming language changes very fast. Some of these language features that existed before 0.4.0, they don't work anymore in this. So if you go online, yes, if you go online and see something and then you come and you try to run it here and it doesn't work, and don't say that thing is because maybe it belongs to a different version, maybe keeps changing all the time. There was a time that constructors within smart contracts, we use the name of the file itself. Right now, we don't use it anymore. We use the keyword constructor. So many changes. Okay.
Yeah. So, Ronald, again, we just running out of the time, and we just want to wrap up. So,
okay.
Again, but based on what you told me, so I mean, I'm coming from the JavaScript coding background.
Right.
When I look at your code, I can tell you, no, it's much more than that.
Yeah.
And it's just, I can see that it's just JavaScript, and you have to do something object-oriented, pure object-oriented, like
yes.
Right.
Right. It's now we have object-oriented JavaScript. We have it now, and it's similar to C++ because it's compiled, right? JavaScript is not a compiled programming language, but C++ is compiled. Right, and then you compile it into bytecodes. This has maybe because of time I couldn't talk too much about this, but I wanted to go deeper into these things and then show you. But we are running out of time. Okay.
Yeah. Just can you go to the slides back, because we just want to wrap up for the last 2 slides, and then if someone interested to really, because in a very short webinar, I mean, you don't want to expect to really master this, because
yes
30 hours of
practice. Okay, so once your smart contract is deployed, right, You see no errors. And then you come down here. You come down to the console, right? All the information about the deployment is here. You see where from, to, transaction costs, everything, the hash, input, the code, everything. All the information is here, okay? So we'll talk about all these things in detail in the class.
Yeah, so now you can go back to the slide to wrap up. And again, for those interested into learning this subject, of course, definitely the PowerPoint slide at the end, there's a contact information that you can reach us. And Reyno is going to be one of those teachers that's going to teach this course for us. And so it just was a glimpse to me and to other people who just know some background of coding. At the same time, they just want to know where they can go from here based on the prior knowledge of coding that they have.
Hold on.
If you minimize this screen, if you minimize your browsers, you can see the slide. Just minimize this.
Hold on.
Yeah, just minimize this. It will be okay. Yeah.
Hold on. Hold on. Okay. So, okay. And then the last. Okay, so this is the contact information, follow up.
Yes, basically, I mean, everyone has this slide. I just shared the link. So we offer like 2 classes in blockchain development, and anyone that want to learn the blockchain, suggest them first to start. If they know JavaScript, perfect. If not, learn the JavaScript. Then we offer them object-oriented programming course, which is a standalone course. And then once the student knows JavaScript very well and object-oriented programming very well, then we can let them take this class, which is Ethereum with Solidity and smart contract. And on the other hand, if someone want to learn the Hyperledger IBM, which is a separate course, they need to know JavaScript. And I'm not sure how far you need to know object-oriented, but maybe some understanding of object-oriented is good, because even Hyperledger uses object-oriented too.
Yeah, basics. I mean, Hyperledger, you know, Node.js. Node.js is fine.
Okay, Node.js is fine. Okay.
Yes,
so,
Node.js is fine.
Yeah. So, thanks again, everyone. I'm just right now checking to see. Yeah. So, thanks everyone. Anyone has any questions want to ask before we wrap it up? Any question before we wrap up, or?
Is everyone okay? Is everyone good?
Yeah, JavaScript. Someone asked, only should I learn JavaScript? I would say JavaScript beginner to advanced level, and then that object-oriented programming, because by default JavaScript is not object-oriented programming language. Just where it comes from.
Okay. Yes. I mean, you don't need to be an advanced JavaScript. Moderate, intermediate. You can pick it up, but it will be very, very helpful or useful if you know some JavaScript, and then you know some object-oriented programming language. It will help you because those concepts are similar, right? You're going to write classes, and then you have storage variables, and then functions. So it will be very good be able to know this. So the URL to your classes, somebody is asking to share URL to your classes.
Yeah, it's on the last slide, just in case. And I'm also right now sending it to you guys. Yeah, someone asked the concept of object-oriented programming. Yes, without object-oriented programming, you cannot write the code in Solidity. So that cannot be compromised. That cannot be. So you
So this,
must know object-oriented programming very well. That was a question someone asked.
um, again, it also depends on, yes, again, it also depends on the individual, but it will help you if you know these concepts, right? Because then it becomes a little bit easier instead of, having to teach you all these things again from the beginning. So it will help you very much if you know these concepts, but because in some aspects it's similar to object-oriented programming language and then JavaScript.
Yeah, because the screen that you show me, I mean, I'm coming from JavaScript, but I don't have a good understanding of object-oriented. And when I was looking at your slide, I was a little bit felt like lost,
Yes.
So, so I feel that object-oriented is very important. Now, anyone, so is there any other question? I shared the link for all 2 classes that we have. And again, thanks everyone for showing up on time and then having this kind of webinar. We look forward to having other webinars we're gonna have about cybersecurity and blockchain, another webinar about specifically on the Hyperledger and blockchain. So just keep up our meetup group, and if you want to sign up for classes, just reach out directly to me through the link I send you, and we'll be happy to talk about our classes. And have a wonderful weekend, everyone, and have a nice evening. So Reynold, you can also close the the recording, and
okay.
Yeah, you just finished the recording, and then I think it would be good.